Okay, so next up, our next function is called lowercase all words. So let's copy that one, and I'm in wordcount.scala. Come down here to the bottom and say I want to lowercase all words. So this one's taking in a sequence of strings. So I'm going to call that list of words, and that's going to be a sequence of string. And it's also going to return a sequence of strings, so we can do that like that. And if this one seems intimidating, fear not. There's actually a straightforward solution to this one. So we take list of words, which again is the sequence, and this is where our trusty map method comes in. So now we want to take map, and then we want to say for every word, W, I just want to call word.toLowercase like that, and we can get rid of that. And if you're familiar with Scala, you know that this is the long form of that. And it's kind of readable because then you can come over here and say, well, for every word W in that list, I want to call W.toLowercase. But what you can do in Scala is replace that like that. So in Scala code, you usually find that. And this little underscore right here is just a placeholder for everything I just deleted. So it's actually a placeholder for each element in that list of words. So let me copy that and come over here and we'll say test. Have that there. Then we can copy this. And this is not going to know anything about blank spaces. So again, that would be a precondition of that method. And this one should be now, that would be big, belly, burger, and all three of these would be in lowercase. And then I want to assert that lowercase all words on in. And I'm doing something wrong, and I will correct that. If you're following along, you may have noticed that I'm doing something very wrong there. And so if you're following along, you notice that that is incorrect. That's supposed to be a sequence. So that would be a sequence where those would be capitalized. There. And then if you'd like to see your test fail, what I'll do is turn that to an E like that. And let's save that. And we come over here. And whoops. I have another problem first. Save that. And again, very nice output here. Burger's not equal to burger. So then we come over here and just not undo, but change that to a U, to a B. There we go. And again, with just this one test, that seems to work just fine. And now let's see what we have to do next. So we have the next function. So this one is going to convert word list to word count. Ooh, that's going to be a fun one. Okay, let's copy that. Come back over here. Things are about to get interesting, I can tell you that. So this one's going to take in another list of words. Right, it's taking in a word list. And then word count, if you recall, was going to be a map. So that's going to be a map of string to int. So what we want to do in the end here is return a count, and I should have that over in the book here. So again, it's strings over here as the keys, and then the count is going to be the values over here. So that's the type of map we're trying to return over here. And this one's going to be interesting if you haven't seen this before. So what I want to do is I want to do a group by, and this may not make any sense initially. Actually, let me just write out the code and then let me explain it. I don't know if that's going to be better. Let's try that. So I want to group by the identity. Okay, maybe I should explain this as I go along. Bear with me just a moment. Okay, in the Scala cookbook, I wrote about this. So group by is a method that lets you split a sequence into subsets according to a function that you provide. So what I showed in the Scala cookbook was this list right here for x of s, and then I call group by on that. So we have that list, x of s, so I'm saying group by elements that are greater than 10. So what it does is it partitions these results, or it groups the results into as many groups as it needs inside of a map. So because of this algorithm right here, it's going to create a map that has elements that are either false or true, or more accurately, the two keys are going to be false and true. And the true ones are going to be all the ones that are greater than 10. So true. So this again returns a Boolean for every element in the list. If the element is greater than 10, put it over in this group over here. So 15, 20, and 12 are greater than 10, put them over there. Otherwise, if they're not greater than 10, that's false, and then put those in this list over here. So it does a couple things for you. It creates these keys, first of all, as it's going through. And again, it will create as many keys as it needs to for your algorithm. And then it puts all the values in the values for each key. So that's kind of what group by does. Another way I can demonstrate group by is with this algorithm. So what I'm doing here is I'm creating a range from 1 to 10. Then I convert that range to a vector. So that creates a vector with the elements 1 through 10 inside that vector. And then I call group by in that. So I say where the modulus divided by 2. So let me just hit enter there, and you'll see what that gives us. So the modulus divided by 2 returns these two values, 0 and 1. So those become the keys. And what happens is all the 0 ones, the modulus, the remainder, is 0 for all the even elements, and then that's 1 for all those. And what I could do there instead was just say, well, where the modulus divided by 2 is equal to 0. And again, this gives us a different result. So now where the key over here for the first map was an int, this one is a Boolean. So all the false values over here are all the odd ones, and then all the true ones are all the even values, as you see in there. So that's another group by example. And now to show you another example here, what I'm going to do is create that sequence first. So that is a sequence of strings right there, and then I'm going to call group by in that. So let us do this. So I can say group by, and this is a little bit of an unusual technique, but what I want to do is say, and actually, let me fix something real quick here. I want to make that x of s because that's usually what we use for a list. So now I want to say, it was about to get confusing what I was going to do. So let me do x of s, and I want to say group by. And now x of s contains all these strings. So I want to say for every string, what I want you to do is just yield that string. And let's see what that does for us. Okay, so that's interesting. This one creates more keys. So it creates this A key. So it found A here. So it says, oh, one of my keys needs to be A. Then it finds B. It says another key needs to be B. Finds C. Another key needs to be C. So that's what happens there. And then as it starts marching through here, it starts doing this grouping action. So it did A, B, C to create those keys. Then it finds another A and it says, you know what I'm going to do? Start making this list. So now I've got a list of 2 A's that I found in this string over here. And then, whoops, I found another C over here. So now I've got a list of 2 C's. And then I just have this 1 B so far. And so that's what group by can do for us in a situation like this. And now you can imagine having as many words in a document as we need to. And it's going to create this data structure like this. So that would be, if we go back here, and we could say, well, give me another A. How about a D? And maybe a Z or something like that. So we do that. Then we come back up and group that again. And now you see all these keys, A, B, C, Z, and D over here. So one thing you can see right away, they're not sorted in any particular way. And then one more thing I want to do here is change this code. So there happens to be a little shortcut for that. And I promise not to do too much Scala magic, but this actually might be a good place for this. Scala has built into it this thing called an identity function. So it's defined for situations like this. So if we wanted to create our own identity function, we would say identity of A. So what it does, bear with me just a moment. Sometimes I can't talk and type at the same time. And I want to say A equals A. Okay, so all the identity function does is it takes a value A with a generic type parameter A, and it just returns that value. And that's exactly what I'm doing here. And that's why this identity function works right here. And again, this is built into Scala. And it is just shorthand for doing this. And if my code is right here, I should be able to use that instead of identity. Okay, and there we go. So again, now we have these groups. For A, I found 3 occurrences of A. B, I found 1 occurrence. C, I found 2. Z, 1, D, 1. And that's how that code's going to work right there. So in our code, I'm going to use identity, but I just showed you here how that works. Okay, so now that I have that, let's come over here. I need to just finish this up. So I need to return a map of string to int. And what I have right now is this data structure over here, which is a map of string to a sequence of strings over here. So the data looks like this. And now I need to turn these guys into an int. So you want to do something about the length of each one of these values over here. So I still want these as the keys over here because these are unique. And then I want the length of each of these as the values over here. And to do that, we have to do, and this is just some Scala stuff that if you know group by and you know what I'm about to do, then you know that you're going to have to convert that to a view temporarily. And now I want to call map values on that. And now I want to transform those values. So this is each value in the map. And you can think, well, what I want to do is each one of these values over here is going to be a sequence. So that's why I use x of s right here. And then I'll say, I want to transform those values to their size. So for each sequence, I want to convert it to its size. And then finally, I want to convert that to a map like that. And that should transform us back to a map. Let me save that and see if I have any errors here. Okay, all good so far. Let me get that one out of the way. And now I want to copy that. And we can test this guy. See if I made any mistakes in our tests. So I want to do that. And of course, I created a very good sequence to work with over there before. So that is going to be our input. And now the output is going to be a map. And what I expect this to be is I'm going to expect to see, what do I have there? 3 A's, 1, 2, 3 A's. And I'm going to have some B's. And I'm going to speed this up so you don't have to watch me type. Okay, and if all is well in the world, then I should be able to do an assert on that. And again, I want to convert the word list to the word count. And we're going to pass that in and then say that will equal out. And we'll save that. And as you see down here, everything succeeded. So convert word list to word count succeeded. As usual, you want to run more tests. I usually do like to see failure first, so let me check that fails properly. And it does. So go back and get it to succeed again. So that's cool. We have all these functions working. And looking at the book here, I am on the wrong page, right? Because that's the initial map. And then the last map is we want to sort the map by the highest value. And again, this is just another case where you need to know a little bit of Scala. So you'd say, I'm going to have a map of string to int as input. And then I'm going to have a sorted map over here as output. And that sorted map is going to be a vector map. So if the IDE didn't do that for me, I am going to need to import a vector map here, there, and I'm going to need to do it in a test as well. So let's go ahead and import that over here. Let's save that, come back here. Oops, this needs to be a map, like that. And this particular solution comes from the Scala cookbook, which I wrote. And I had to do a fair amount of research to get this guy right. So I just pasted this in. This solution comes from the Scala cookbook, and I formatted it this way. I might normally have that code like this, but I thought it might be easier to read on multiple lines. So let me go back to that for, at least just for our purposes here. So what this one is doing is it's going to create a new vector map. So you can think of this as being the constructor for a vector map. And then what I'm putting into that constructor is I'm taking our initial map, I'm transforming it back to a sequence right here. And I'll show some more of this in just a moment, but I'm taking our initial map, I'm transforming it back to a sequence, and then I'm sorting it with this formula. So this is really interesting. This sequence is going to be a sequence of tuple values because I transform a map to a sequence. When it does that, it creates a sequence of tuples, two-element tuple to be specific. And then over here, I transform each tuple using this expression right here. So bear with me for a moment. Let's come back to this. I want to get the test going first. So let's come over here and so run this test. Come over here. So what I'm going to do for that one, let's start with this map over here. And we can make it simpler and just get rid of those last couple there. So as you can see, this map, which I'm going to call in, is unsorted. And then what I want to say is after we call the function, this should be sorted. And it should be sorted by the value over here in descending order. So the result should look like that, or more specifically like that. And come back over here. And I want to assert that sort map by the highest value. So I'm going to pass the map in, and then I'm going to say that should equal the map. And do my usual error right there. So I'll say, how about 17? And that should fail. And then I can look here and say, well, this is what we expected was that, and then that failed. But you can see 3, 2, and 17. So that's actually a good start. Let's get rid of that. And save that, and hopefully everything will be green this time. And there we go. So technically we're done with all the tests, but I want to explain how this works. So let's come back over here, or indeed, let's come back over here. Bear with me just a moment. Okay, let's start with that. And I'm putting this in the REPL, so this is our test map. I just pasted that into the REPL. And let's come back to our algorithm. So I want to show step by step what's going on here. So again, that's a vector map constructor. That's part of the simple part. I'm not too worried about that, but what I want to show you what in.toSeq looks like. So let me change the name of that. Just to be a little more meaningful, we'll call that map. Now you can see map is a map of string to int. And now I want to convert that to a sequence so you can see what that looks like. And now you can see what that creates here is this sequence, and this one happens to be a list specifically, and it's a sequence of tuple elements, okay? So a tuple, this is a two-element tuple. Each tuple contains two elements. The first one is a string, the second one is an int. So you can see, and again, these are going to be the counts over here. So this is the first tuple inside there. Again, that A should be enclosed in double quotes. So you can see that the values that this tuple contains is the string A, and then it says, well, A occurred 3 times, B occurred once, and C occurred twice. So now that we have the sequence, we want to work on that so we can get these things into sorted order. And we do that with this sorting algorithm right here. So we can just copy that guy right there. And now, so I've got map.toSeq, and I want to call this on here. Oops. And let me add a little spacing right there. And now we have sort with. So sort with is a method that's on the sequence types. So I want to say sort with the following algorithm. So to sort this list over here, I need to understand these types right here. So the sequence contains, again, tuple values, and the first value is a string, and the second one is an int. So what I could do to make this code a little more meaningful, actually I can't do that. It really is doing tuple 1 and tuple 2. It's comparing 2 tuples at a time as it marches through the list. So it really is comparing tuple 1 to tuple 2. So I need to keep that. And then it's saying what's going on here is that this is the value in each tuple, or the second element in each tuple. So it's referring to that int. So scratch that part about the value. It's referring to the second value in each tuple. And that second value here is, of course, an int. So it's comparing these 3s and the 1 and the 2. That's what this code is doing. And all of this is an anonymous function that says, start with these tuple values here, then transform them. Again, this is the transform operator. Start with these tuple values, transform them into actually a Boolean. So this is comparing value 2 from the first tuple to value 2 in the second tuple and saying, is this one greater than that one, true or false? So is 3 greater than 1? Yes, it is. So that's true. And then it'll march through and say, is 1 greater than 2? No, it's not. So that one's false. And then it keeps doing that. So if I hit enter there, I'm going to get an error. And I knew that actually. This guy here is not part of that code. So do that. Okay. And now we have a sorted sequence. So again, this is another sequence of tuple values, just like we had before, except now they're sorted. So A occurs 3 times, C occurs twice, B occurs once. And then this little part here is a little bit of Scala magic. I don't actually like that one, but let me explain it for you. Come back over here. So what that does is this is like the splat operator in Unix. So if you know Unix, you know what that means. So basically, it adapts. This guy is a sequence, right? And it happens to have these 3 elements in it, these 3 tuple values. So what this does, the return value from here, the return value of that is this sequence right here, right? So a list of these 3 tuple elements. This syntax right there says, take each one of these tuple values one at a time. So take that one and feed that into the vector map constructor. So vector map says, oh, okay, I got that first tuple right there. And then it says, okay, now I'll give you the second one. And that goes into vector map. And then the third one into vector map. So there's kind of a weird thing where you can't put this list directly into a vector map constructor. So what you have to do is adapt that list using this magic sequence right there to do that work for you. And again, this is very similar to the splat operator in Unix, so I assume that's where it came from. And again, all it does is convert this list into something that vector map can handle. And if I really understand what's going on, I should be able to come over here in the Scala REPL and say that. And now I can show you that I want to create a vector map. Let me see if I can show you exactly what's going on here. So what I'm thinking is, without looking at the vector map constructor, I think vector map expects to be able to take, oh, actually I can see it right there. Vector map expects this symbol right there. So it doesn't take a sequence of elements like this, but it takes a varargs parameter right there. So it takes, and I showed this in the earlier videos what a varargs is, but that means it's a variable number of elements. So this takes a variable number of key value pairs as its input. So coming back over here, this would be like taking A is 3. So that's one way to create a vector map, and you can see that. And now, as I mentioned, that takes a variable number of tuple elements. So now I can give it a second tuple element as part of that variable part. And let's just give that a different number just to make things different. And you can see it takes that. And also note as they go along that it's retaining the order of these, and that's what a vector map does for us, is it saves the order that we are putting into the constructor here. And so I do that like that. So again, vector map takes a variable number of tuple arguments. So in this case, I give it 1. Here I give it 2 tuples, and here I give it these 3 tuples as input. And in summary, that's how that code works right there. And if all of this seems a little unusual, I do describe this in the Scala cookbook. I think I also have this recipe on my website. And it's just a way to sort sequences with the sort with method. And in this particular case, the sequence contains tuple elements. So then we're sorting by the second element in the tuple. So at this point, if we go back to the book, we can see that we just implemented the last function over here. And by the way, I forgot to mention it, but we implemented all of these as pure functions, right? Because each one takes an input value like this, it transforms it into a resulting output value. Every function has a solution. That is, for any value that comes in, it will return a value. So in all these cases, there won't be any exceptions thrown by any of these functions. Or at least I think so, based on these tests right here. So if we continue to write more tests and we find that one of these functions doesn't return a value in some particular situation, or it throws an exception, then we'll just come back here and fix this code. But for right now, I believe all these functions are pure functions. And another thing you see with all these functions is that it didn't have to use any mutable variables. That is, using the var keyword, I didn't have to use anything like that. And I also did not have to use any mutable data structures. I didn't have to use a mutable array buffer, a mutable array, or a mutable map. And I should note that the split method right here did return an array, but I quickly convert that back to a sequence because I don't want an array bleeding out in my code over here. So when I'm forced to have an array by one of these methods like that one, I want to convert it back to a plain sequence, which is immutable when I return my sequence right here. And finally, if you're interested in working with these examples in this code and you want to add more tests or whatever you'd like to do, you can find those examples at this URL on GitHub.